a recording now. Okay, so we are going to cover 3 sections today. All right, and the reason that we're going to cover 3 sections today is because back in December when I had you, we did adding, subtracting, and multiplying polynomials, and we did those in single variable and in double variable. Okay, so since we've already covered that, since I know I covered that with you in December, I'm pretty sure your regular 8th grade teacher covered it. All right, and then me doing it now today, really technically probably is going to be like the 3rd time that you will have seen this. So we're looking at section 9-1, section 9-2, and section 9-3. All right, and then I'm even going to add a little extra review in here. All right, you're going to have some questions in Math Excel that's going to deal with the degree of individual terms. We went even farther than that. Last year, we did degree of the entire polynomial. Okay, so let's take a look at that degree first. All right, we can do degrees of individual terms. Okay, so if I had just like 9x squared, okay, go ahead and call this an example. All right, all we have to do is look at that exponent because there's just a single variable there. That term, that individual term, has a degree of 2. Okay, now what I had done, which is usually not necessarily done in an Algebra 1 class, definitely in Algebra 2, you're going to see things like maybe a 23x squared y to the 4th. You're going to see a couple of variables in there, okay? In which case, to get the degree, we add those up, okay? So 2 plus 4 there is going to give you a degree of 6 on that term. Doing one more here, technically, I can have a term in my polynomial that doesn't have any variables at all. So I could just have a constant sitting at the end. So if I had just, like say, a 23, and I wanted to know the degree of that 23, all right, there's an imaginary x to the 0 power, right? Because when we did our last chapter, anything raised to the 0 power is always 1. So technically, constants do have variables. They have x to the 0 power. All right, which would mean then that my degree of that would be 0. All right, so those I think in Math Excel they're just going to ask you individual terms. But last December, we did a little bit more than that. I gave you entire polynomials. So I might have given you something like a -6x to the 5th plus 2x to the 3rd minus 3x plus 7. Okay, polynomial in a single variable. All right, and then vocab words, which you might have forgotten at this point. We looked at this. The exponents were in decreasing order. Okay, so we said that this was standard form. Okay, so again, that's review. I made you identify things like the coefficients. So the coefficients were -6, 2, and -3. I made you identify the constant, which was the 7. All right, I also made you identify the leading term. So as long as it's in standard form, this is the leading term. Okay, I know last week we had some people that had like asked questions about that, and it's probably just because you'd forgotten it. It didn't go into long-term memory. All right, once I've identified that leading term, I could ask you what the coefficient of that leading term is. Okay, so of this leading term, my coefficient is a -6. All right, and then I could also do the degree. Now the degree of the entire polynomial is 5, all right, but the degree of that individual term is 5 as well. Okay, so that pretty much for an Algebra 1 class, they're usually going to just do that in a single variable. All right, but there's no reason why I can't do this in multiple variables. All right, we had done this, I did this last year when you were in the 8th grade. Okay, so let's do this again. Let's say we've got a polynomial, just a random polynomial, maybe say 3x squared y to the 5th minus 5xy to the 9th plus 10x squared minus 6xy to the 4th, I don't know, plus 7. Okay, I'm just getting kind of long here. All right, this would be a polynomial. Okay, I'm not necessarily going to say written in standard form or anything. I just randomly wrote a bunch of terms down. Multi-variables. I've got x's and y's in some terms. This one just has an x. This one's just a constant. Okay, now if you remember what we did on this one, we had to calculate the degree of each individual term because we had two variables. Okay, so for this one right here, all right, I'm going to do the term just like I did up there earlier. Up here, I added the exponents. So a 2 plus 5 is going to give me a degree of 7 on this one. There's an imaginary 1 right there. So I'm going to add the exponents there. 9 plus 1 is going to give me a degree of 10. All right, this one, there's nothing to add. It's just like this first one right here. So it has a degree of 2. I am adding here with that imaginary 1. So 1 plus 4 is going to give me a degree of 5 right there. And then this has that x to the 0 power, so this degree is 0. All right, and if you remember when it was like this, then we took the degree of each individual term, and then we picked the one that was the biggest. All right, so clearly this term is the biggest degree, so that's going to be what's considered to be my leading term. So this one is my leading term, even though it's not in front. All right, it is considered to be the leading term because the degree is the highest. Okay, the degree is 10. All right, and then squeeze it on there. The leading coefficient, my coefficient for that term. All right, and if you notice, when I circled this, I circled it really big and I got that minus sign in there so that I could see that my coefficient there is a -5. All right, so all of that, okay, definitely done last December with you, and then we even did it early on this semester right after we came back to school. All right, so anybody have any questions up to now? All right, you just got to unmute your mic and then ask questions, and don't hesitate to interrupt me at any point in time. If I'm going too fast or you need to see something or you have a question, go ahead and interrupt me. Okay. All right, so I think I'm going to move these pieces of paper, go to a new piece of paper. All right, now also in this, we're going to be adding, subtracting, and multiplying. We're going to be doing a little bit of all of those. This is going to involve your laws of exponents. All right, we just did that chapter. When multiplying like bases, we're going to add those exponents. Okay, so when we do the multiplying, that's what we're going to do. I believe as we were doing examples last year, I kind of emphasized that adding polynomials, subtracting polynomials is no more than adding and subtracting like terms. The problems will look different though, because what they're going to do in the book is they're going to put a set of parentheses around them. Like so 4x to the second plus 6x minus 7. And then let's go ahead and start with a subtraction one because that's going to be the hardest. Not really that it's hard, but more challenging than add. And then the second polynomial might be a 3x squared plus 9x minus 3. All right, they're going to call this type of problem adding, subtracting polynomials because this set of parentheses around here indicates this is your first polynomial. This set of parentheses indicate that this is your second one. All right, now when this is a subtraction, what's that tell us to do? It tells us to go through and change all the signs. All right, if this was add, it literally would be no more than adding like terms. So I don't know, we don't want to scribble that out too much, but I definitely want to go through and show that those signs are changing. So -3x squared minus 9x plus 3. Okay, most of you are going to be able to do this in your head, but if you write it down, you're definitely not going to make a silly mistake. All right, go through, combine like terms. All right, 4x squared minus 3x squared is just going to give me an x squared. 6x minus 9x, okay, it's going to give me a -3x. -9, or sorry, -7 plus 3 is going to be -4. All right, so these problems are pretty simple, okay, adding and subtracting. Let's do an add one. I'm not going to do tons and tons of examples because we have done this so many times, okay, before. If you need to see more examples, just let me know. This is pretty much the horizontal method, and a lot of times they write the problem this way. There also is a vertical method. You might see a problem where it's written up and down instead. So maybe you'll see a -5x to the 5th minus a 4x to the 3rd plus 6x. All right, and then vertically underneath it, maybe we'll see a 7x to the 5th. And then they could, if the terms match, they're going to line them up for you. If they don't match, They might leave nothing here, leave a big space here, and line up an x term. Okay, but let's just assume we've got both of everything here. So a 5x to the third and then minus a 9x. All right, so that would just be the same type of problem. I'm still adding two polynomials, my top polynomial and then my bottom polynomial. Okay, they're doing this. They're really making it super easy for you because you have lined up all of your terms. Okay, so you're just going to add like normal. You're going to have a 2x to the fifth here. Subtracting there, I'm going to get a 1. I don't have to put that 1 in. X to the third, and then a minus 3x. Okay, and again, don't let me make any silly mistakes here. I'm doing this math off the top of my head. The add and subtract is really not too bad. Now, in December, I made it a little bit more challenging. We didn't do everything in a single variable. I should be able to do some of these and have an x and y in them with some different exponents. All right, because again, since it is just adding and subtracting like terms, we ought to be able to handle that. Okay, so let's take a couple look at least one example of more than one variable. All right, let's go back to the horizontal method. Let's say that polynomial is maybe say a 2x to the third y plus a 5x squared y squared minus 6x. And let's say we're going to add to that then maybe a negative 8x to the third y plus 2x squared y plus 5y. I'll give you a minute to write that down. Okay, so this is more on the lines of what you would see in Algebra 2. All right, but the concept is easy enough. If you can do this in a single variable, then you can do this with multiple variables because the concepts are the same. I need to go through. Obviously, this is a polynomial. Got a set of parentheses around it. This is a polynomial. Okay, now I'm going to go through and I'm going to look for like terms. Now, if you remember, like terms have to have all the same variables and all the same exponents. Okay, so that means this one and this one are like terms because they both have an x to the third y. All right, the 5x squared y squared, that matches x squared y squared here. The coefficients don't have to match, just the variables and the exponents. Okay, then on this one, I have a minus 6x. There's no x term over here, and that's okay because I don't have to have everything matching. All right, and then over here, I've got a plus 5y, and again, nothing matches with that, and that's okay. Okay, so if I'm going to add this and put this together, all right, keep in mind, when I add or subtract like terms, I get a like answer. When I add like terms, I get a like answer. So the only thing that is affected is my coefficient, my variables, and my exponents stay the same. So I'm just going to take those coefficients. 2 plus the negative 8, that's going to give me a negative 6. I'm going to keep the x to the third, and I'm going to keep the y. Then I'm going to go to my next like terms. Okay, I'm going to add those. I'm going to add the coefficients. I'm going to leave my variables and exponents alone. So that's going to be a 7x squared y squared. All right, and then these two, since they don't have any like terms, I just have to be sure and bring them down and include them in my answer. So minus 6x plus 5y. All right, then I can just make sure, look to make sure that I don't have any like terms. I do not. So then I am done. I have put that together. Okay, and I had you doing this last December. Okay, so hopefully that, a little bit of, example here, and it's going to come right back to you. Again, don't worry about trying to put it into a standard form or anything like that. If you notice the way I did it, I just kind of did it left to right. When I put those two together, I wrote that first. Then I put these together, I wrote that next. So logically, when we read left to right, write your answers left to right. Okay. All right. So I think that for adding, subtracting, since we have done it so much, I think you should be good there. All right. I'm going to take a look at some multiplying. Okay. Now we do need to remember when multiplying like bases, we add those exponents. All right. So let's write that down as a review. That came from our last chapter. Okay. It's a law of exponents. When multiplying like bases, we add, that's the crucial part, add the exponents. And that just is used a lot in this polynomial whenever we're multiplying our polynomials. Okay, so that concept in and of itself is a review as well. Okay, so obviously you're going to start out with just your basic Algebra 1 problems, which are going to have just a single variable. and maybe no more than just two terms. Okay, if you remember, like as early as 7th and 8th grade, you were distributing. Okay, that's all we're going to do. We're going to do repeated distributive to multiply this stuff. Okay, so I could have maybe say a 4, if we go really simple, just a 4 on the outside and a 2x squared minus 6 on the inside. All right, this would be just a number times a binomial, but it's multiplying polynomials because those can be considered that. All right, and we repeat the distributive property over and over and over. Okay, so that's going to be an 8x squared and then a minus 24. These are not like terms. At that point, I'm done. Now, notice I didn't have to use that rule because I only had one variable in there. So you don't always have to use this rule. You only have to use that rule when it shows up. All right, now, last December, I had you doing maybe variables out here, like I gave you a 4x or a 5x squared, and I gave you definitely more than just 2 terms on the inside. Okay, because again, once you get the hang of how you're doing this, the concept stays the same. So let's put like a negative 3x squared on the outside. Let's go ahead and put maybe say 3 terms in there. Let's do a 4x squared minus a 3x plus a 5. Okay, so I can have any number of terms on the inside, and technically I can have any number of terms on the outside. This right here is a monomial, all right, times a trinomial. So vocab words that you ought to be used to. Okay, so we're going to go ahead and distribute more than one time. I'm going to take that negative 3x and distribute to everything that's on that inside there. Okay, so negative 12x. Now, this is where I'm going to implement this rule. When multiplying like bases, I've got to add those exponents. So 2 plus 2 is going to give me a 4 there. All right, negative times negative there is going to give me a positive 9x. All right, now we don't want to forget the imaginary 1 that's sitting right there. So 2 plus that 1 is going to give me a 3. All right, multiplying the negative 3 and the 5 there is going to give me a minus 15. There's no variables here, or we could think of it as an x to the 0 power, as we saw earlier in the lesson. But regardless, it'll just be an x squared. Okay, so again, I had you doing this last December. You did this on your final exam at the end of the semester last year. Okay, so hopefully these 2 examples, everything's coming back to you rather quickly. All right, now both of these were a single term on the outside, multiple terms on the inside. Okay, let's go with a binomial times a binomial. Okay, so if I had something like a 2x minus a 4, and then a 3x plus 5. All right, we have done this earlier this year as well as last December. Okay, this, you can do repeated distributive property, which is usually what I do. All right, or you can do that FOIL method, which we should all have remembered. You know, first terms, outside terms, inside terms, last. All right, I have a tendency not to do that. But when I do repeated distributive property, this naturally comes out. Okay, so I'm going to do my repeated distributive property, and then I'm going to show you how it just kind of naturally falls here. So I'm going to take this term right here, and I'm going to distribute it to the 3x. All right, I'm going to go ahead and multiply that, and let's just do it all at the same time here. So 2x times 3x is going to give me that 6x squared. All right, then I'm going to distribute that same term to everything in that second binomial. So 2x times 5 is going to give me a 10x. All right, now technically, didn't I just do FOIL? First terms, these are my first terms, and I multiplied those first. And then outside terms, well, that's this term and this term. These 2 are the outside terms. So by doing repeated distributive property, I am in essence doing this. Okay, now I am going to color code this here. So now I want to take the next term that's in the first one and multiply it by the first one there. So a negative 4 times that 3x minus 12x. All right, and again, aren't those the inside terms? So I'm following FOIL, even though all I'm doing is repeating my distributive property. And then the negative 4 times that 5 is going to be the minus 20. Okay, so you can clearly see where these 2 came from distributing the first term, these 2 came from distributing the second term. And again, we've done this so much, you should already be really good at this. 6x squared minus 2x minus 20 there. And I've got a nice little trinomial, okay? So I just wanted to do one like that. Again, last year, I think I had you doing a binomial here, maybe 3 terms inside here, 4 terms inside there. So we had lots of repeated distributive property. I do want to do another one of these because I notice how I wrote this whole line horizontally. If, especially by the time you get to algebra 2, you're going to have three, 4 terms here, 3, 4 terms here, and doing it horizontally can really get messy. All right, so another way, just another approach in how you do it. Let's do one more here. Let's do like 3x squared plus 5x, and then let's do it, maybe say a 2x squared minus a 3x plus a 6. Okay, let's just do a binomial times a trinomial because we don't want to get too ridiculous here. Okay, now I'm going to kind of implement, instead of going horizontally, again, I'm going to try to implement a vertical method here. I'm going to do repeated distributive property. So this 3x squared is going to get distributed to every term in the trinomial. Okay, so when I multiply these two, I'm going to write down 6x to the 4th. Okay, because when multiplying like bases, we add those exponents. Distributing here, minus 9x to the, don't forget the imaginary 1, 9x to the 3rd. Distributing here, 18x squared. Okay, now when I go to distribute the 5x, I could keep going with that horizontal method, but would have tons and tons of terms and it would be really, really long. So I'm going to go vertically. If I multiply 5x times that 2x squared, I get 10x to the, again, don't forget the imaginary 1, to the 3rd. All right, well, if I know it's an x to the 3rd, I know it's matching terms right here. So why not go ahead and do plus 10x to the 3rd, line up the matching terms, because what am I going to do when I get that great big horizontal line? I'm going to add like terms. So let's go ahead and line them up ahead of time. All right, when I distribute here, I'm going to have a minus 15. And then it'll be an x to the 2nd. And again, it's automatically lining up with those like terms. Okay, I do it again. 5 times 6 is going to be that 30x. And then I just wrote it over here because I don't have a like term. Okay, so just another method. And when this gets really, really long, this helps. Okay, everything is now matched up for you. Okay, so I'm going to have a final answer of 6x to the 4th. Right there, I'm going to have x to the 3rd. Subtracting there, I'm going to have a 3x squared and then a plus 30x. And again, don't let me make any mistakes. If you're seeing any mistakes, somebody yell at me. Okay. All right. So again, all of this hopefully is just review and it's coming back and it's kind of simple. I think I do want to show one more. Although I don't know here. Let me go look at my calendar real quick. Because if it's on a different day, I don't need to necessarily do it today. Difference 2 squares. Let's go ahead and do another example, just because I don't know if it's going to show up in today's homework or not. So let's go ahead and do at least one more here. Okay, let's take a look at maybe say a 2x to the 3rd plus a 5, and then raise to the 2nd power. Okay. All right, now we know that if I take 4 squared, what's that mean? It means that the base is a 4, and I am supposed to take 4 times 4. Okay, we know that you've been doing that for a long, long time. Okay, so the question here is, what's my base? Okay, this one has a base that is a binomial because it's got a set of parentheses around it. Okay, so just like I took this base and I multiplied by itself, you need to take this and multiply it by itself. So you should rewrite this 2x to the 3rd plus 5. And then the exact same thing again, just because I used the exact same number here. So the exact same base again, 2x to the 3rd plus 5. All right, which then what? This makes this a FOIL problem or repeated distributive property. Okay, now the number one mistake that I see on this, and I am going to go ahead and show it, and then just hope you don't do it. I just want you to understand what people do wrong. All right, 2x to the 3rd plus 5. All right, to the 2nd power. So what they do is, because of that last chapter we just did, and we did laws of exponents, and people are thinking, oh, power raised to a power. What they do is they try to square this first term and they try to square the second term. That's not allowed. You can't do it because it's over the plus sign. All right, so a lot of times I will see a 2x to the 6th plus a 25 as a wrong answer. Sometimes people go ahead and square the number in front and give me a 4x to the 6th plus a 25. Again, still not the right answer. Okay, so we do not want you to do this. That's just a common mistake. Actually, let's put common on there. It's a common mistake, all right? Now, you're going to see as I FOIL this out, I don't just get 2 terms, all right? If I FOIL this out, okay, that's going to give me a 4x to the 6th. Okay, that was my first term, all right? Outside terms, okay, plus 10x to the 3rd, plus another 10x to the 3rd. Again, so if I wanted to do horizontal method, I could keep going. If I want to do vertical method, I could do that. So either way, plus 10x to the 3rd. Last terms, plus 25. All right, this gives me that middle term there that I've got to combine, see, 4x to the 6th plus a 10, oops, I can't add, 20x to the 3rd plus a 25. So 3 terms, this gets a really close answer, but you miss that middle term, okay, because this is the wrong way to do it. All right, so actually, I think that's about everything that we need to do at this point. I'm going to stop here.